So hey guys, welcome to Clear and Crisp Coding. In this video tutorial, we would be solving the problem Codeforces ground 651 tip 2b problem GCD compressions. So this was a recent contest and I also participated in it. So now let's see. Here is the problem. You can read the problem. I will attach the link to the description. But if I explain the problem to you in a clear way without missing any important point, then the problem is something like this. So we are given an array of size 2n. That means it contains 2n positive integers and we want to compress this array. So by compressing we basically mean that we want to remove some element from the array such that we can discard exactly two elements. So if there are any two elements, we can discard any two element at max and at min. We have to discard exactly two. And then on the remaining elements, so suppose there were 2n element, so we discarded two elements, then how many were left? 2n minus 2. And then on 2n minus 2 elements, we have to do this operation. Remove any two remaining elements and then add them to a new array B. So the B would be the compressed array, and we have to do this thing in such a way that the GCD of all the elements present in B should be greater than 1. So this point is really important. This basically means that all these elements in B should have at least one common divisor, which should be the GCD of all the element, and it should be greater than 1. It should not be 1. That means they should all not be relatively prime. Okay, so this is the main point, and here it is given clearly that the given input would be such that it would always be possible to form this B array, and I will also prove that it is always possible. So now let's get to the explanation and then we will see the code. So there were some edge cases which we need to handle really carefully. That was handle the runtime error, and also there was one more. For n equals to 2, if you will do the code, you have to be really careful of the indices. And as you can see that I also got a lot of runtime error due to index out of bound, and here you need to handle them. And now let's proceed to the steps. The steps were basically we have to observe the count of even and odd elements in the array. So basically let's take this example of 1 2 3 4 5 of size 3. So n equals to 3, and as our array is something like this: 1 2 3 4 5 6. So basically out of these 6 elements we have to choose only 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 two of them. And how would these two be formed? These two would be formed by deleting any two element from this array, and of the remaining 4 we have to club them by taking their sum. So now let's see. Let's first basically count the number of even and odd elements. So let's see, the odd count is 1 2 and 3. So there are 3 odd elements, and the number of even elements are 1 2 and 3. So number of even elements are also 3. Okay, so now what this means? This means that we can take either to odd or to even, but basically let me make the approach more clear here first. So basically the approach we would be going is that we would be forming an array such that the GCD of that all element is 2. That is the main point. We can always make it like this by removing two element. Let me prove this statement for the above example, that I can remove two element and then take sum of the remaining such that the GCD is always 2. So basically what I want to say is that if we add two odd elements, so odd element plus odd element, it would give us an even element, and if we add two even element, then it will also give us even element. So this is the real point over here which we need to take care. So how would we doing it? So for in this case there are 3 odd and 3 even. We have to discard 2 element out of these 6, and for all the remaining 4 we have to form pairs using this condition such that this is always even, and the GCD of any list of even number is 2, at least 2. It can be some multiple of 2 also, but it is 2. It is definitely 2. So the main point was this. And now let's see how is this question being solved. So basically the three odd positions over here were 1, 3 and 5, and 3 even positions were 2, 4 and 6. So we remove the last one. Let's say we don't take this to the answer, and we added these two. The answer was 4. Then this two, the answer was 6, and we can see that GCD is 2. All right. So this proves for this example. Let's take the other example given in the question. So this was the edge case which I was talking about. When n is 2 and the number of elements are 4, so in that case we can just directly print the first two indexes. And as for this example also, GCD of a single number is number itself. So let's take this example now. Let me just note down this array. So n is given as 5, that means there would be 10 element. 1, 3, 3, 4, 5, 90, 100, 110, 101, sorry, 101, 2 and 3. So now if we count here the or number of odd positions, so it would be 1, 2, 3, 4, 5, 6. So there are 6 odd, and how many evens are there? There are 1, 2, 3, 4 evens. So we can see the number of odd and number of even are both 4 in this case, or are both even in this case. So let's compare this with the previous case. In the previous case over here, we had 3 odd elements and 3 even elements. So what can we observe here? The number of occurrence of odd and even both are also odd. And in this case, the number of occurrence of odd and even both are even. So here comes the another observation, that it is given that the length of array is always 2 into n. This means this number is always even. And as we have taken a look here, that the even number can only be obtained by adding either two odd numbers or two even numbers. If we add an even number with an odd number, then this would never be even. This could never be even if you take any case. So this means that if we want to split these 2n into two groups over here, then either both of them has to be even or both of them has to be odd, as in this case. So in this case, since both of them are even, so from this we can take 4 element and form pairs out of this. That means we can form 2 pairs of 4 element, and from this we can take all the 4 element and form up 2 pairs out of them. This means from this we have removed exactly 2 elements and taken exactly 4. So that means for this the given input size was 10, and we have taken 8 by removing these 2 elements. So now let's go to the code for more clarity. So here is the code. It's pretty lengthy, but I will explain it clearly. So let's see. So here I am just taking a screenshot of the screen. Okay, so here we are just taking the input, and this is where we are handling the edge case. That means if n equals to 2, we are just printing 1 and 2. This would be definitely working. And now here we are just storing this even elements array indexes in even array and odd elements position in odd array, as in the output it is required for us to output the index of the elements. So now here is the first case. If the even number of even elements and number of odd elements both are odd, which means this is the case similar to the above case. This is the first case we discussed. Number of them, both of them is odd. Then how would we select the element such that the GCD is always 2, at least always 2, it could be greater. So here I am just doing a thing that so there are odd number of elements. Let's say there are 5 even element and 3 odd elements. So what I am doing, I am just leaving this element and I am clubbing this and this and this. So if these all are even elements and these all are odd elements, so by clubbing this we get a sum which is also even, this is also even, and this is also even. and all the even have the GCD 2, that is for sure. So I am just here in the code also just leaving this one position for this, one position of this, and then I'm printing these two position, and after every two position I'm just moving to the next line as given in the output format. So, and now the other case in which both of them are even. Here comes a really special case which you have to handle, which really troubled me also in the contest. That was if any of the array, that means either odd or even, is 0 here. So if any of them is empty, so that means the array is something like this. You are given 2, 4, 6, 8, 10, 12. That means all these elements are even. Then how would we handle this case? This has to be handled separately because there is no odd elements. So in this case, if all these odd elements are empty and there are only even element, what I'm doing is I'm leaving these two and forming a pair of these such that their sum would be even, their sum would be even, and 2 would definitely be the GCD of these two. And similarly for the case when there is no even element in the array, I am just doing the same, leaving the last two odd elements and forming these pairs, and sum of odd elements is always even, and the GCD is at least 2, it can be greater than that. And the other case, which would be something like this, when there are both some amount of odd number of even element present and or an even number of odd element present. That means both of them are present in even numbers. So in this what I am doing, I am forming this pair and this pair, and I am leaving the last pair here. Since the size is only 2, then only this pair can be formed. I am leaving this from the answer. So this would be even, this would be even, and for even number what we should know that GCD would always be at least 2. So if I explain this with another example, 2, 4, 8, 10, 1, 3, 5, 7. So what I am doing in this code, in this loop, I am just clubbing all these even elements. So this is clubbed in one loop, and in another loop this is clubbed. And this loop I am only running till this position, that is I am not including this, as we have to exclude exactly 2, and I am including this. So this sum would be even, this would be even, this would be even, and even has definitely GCD 2. So this was the code which was accepted, and I hope I was able to explain you everything. If you had any doubt, please let me know. I would be really happy to help you, and I would be posting more solutions like this. So do subscribe the channel and give this video a thumbs up if you like this. Thank you.